Have you ever stopped to think about what could be inside a black hole? To many, it's one of the strangest and scariest mysteries in the universe. Some people imagine it as a giant cosmic vacuum cleaner, sucking up everything in sight. Others picture it as a hidden doorway, a passage that could lead to another universe or even another time. The truth is, we don't really know for sure, and that's what makes black holes so fascinating. What we do know is that they have a kind of invisible boundary called the event horizon. Once something crosses it, whether it's a planet, a star, or even a beam of light, it's gone forever. No signal can escape to tell us what's inside. It's as if the universe itself has placed a curtain over the truth. Scientists can't see through this curtain, but they can study the way black holes affect the space and matter around them. These clues are all we have, and they hint at something far stranger than anything we've seen before. For decades, physicists and astronomers have been trying to solve this puzzle, using the most advanced telescopes and the most complex equations ever written. And yet, each answer they find only seems to lead to bigger questions. What lies beyond the event horizon? Is it destruction or something entirely unexpected? The journey to find out begins with what we think we know, and ends in a place where science itself struggles to keep up. To understand what might be inside a black hole, we first have to understand what a black hole actually is. A black hole is not an empty space. It's a place in the universe where gravity is so strong that nothing can escape. This happens when a massive star, far bigger than our sun, reaches the end of its life. When it runs out of fuel, the star can no longer hold itself up against gravity. Its core collapses inward with incredible force, crushing all its mass into a tiny, dense point. This is the birth of a black hole. Surrounding this tiny point is the event horizon, the invisible boundary that marks the edge of the black hole. Imagine standing at the edge of a huge waterfall. On your side, the water flows calmly. But once it passes the edge, it plunges down so fast that nothing can climb back up. The event horizon works in a similar way, except instead of water, it's space and time themselves that are falling in. Once anything crosses that point, there's no coming back. Black holes come in different sizes. Some are just a few times more massive than our sun, while others, called supermassive black holes, sit at the centers of galaxies and weigh millions or even billions of times more. Our own galaxy, the Milky Way, has one called Sagittarius A** at its heart. These cosmic giants are silent and invisible, but the space around them is often filled with swirling matter, glowing from the intense heat and energy as it falls inward. Even though we can't see inside a black hole, we can see the effects it has on its surroundings. And those effects are extreme, warping space, bending light, and even changing how time flows. Understanding this nature is the first step before we dare to imagine what lies beyond the event horizon. Now that we know what a black hole is, let's imagine what would happen if you tried to get closer and then cross the event horizon. From far away, everything might seem almost normal. The stars would still shine, and space would still look calm. But as you got closer, you would start to notice strange effects. Light from the stars behind you would begin to bend and twist, as if space itself were curving around the black hole. The closer you got, the more this bending would increase, until it looked like the universe was being pulled toward a single point. Here's where things get even stranger. If someone far away was watching you fall in, they would see you slow down. As you approached the event horizon, from their perspective, you would appear to freeze in place. Your image would become stretched and distorted, and the light reflecting off you would grow dimmer and redder until you faded from sight completely. To them, it would look like you never actually entered the black hole. You just stopped at the edge. But your own experience would be completely different. From your point of view, you wouldn't stop at all. You'd keep moving forward, passing through the event horizon without even noticing the exact moment it happened. Once you crossed, there would be no turning back. You could no longer send signals or light back out to the universe. The outside world would be gone forever, and your journey would continue into a place where space and time are twisted beyond recognition. Inside this strange realm, the rules of the universe begin to change. The pull of gravity would become stronger and stronger, dragging you toward the center no matter what you tried to do. This is where the real mystery begins, because no one knows exactly what happens next. But scientists have some fascinating ideas, and they involve forces so extreme they can stretch matter, time, and even reality itself. Once you've crossed the event horizon, there's no escape. Every moment brings you closer to the heart of the black hole, and the forces acting on you grow more and more extreme. One of the strangest effects you would experience is something scientists call spaghettification, and it's exactly what it sounds like. Gravity near a black hole is incredibly powerful, but it's not the same strength everywhere. The pull on the part of you that's closer to the center is much stronger than the pull on the part that's farther away. If you were falling feet first, your legs would be yanked toward the center faster than your head. This difference in force would stretch your body out, making you longer and thinner, just like a strand of spaghetti. At first, you might not notice much. Gravity is something we feel all the time. But in a black hole, this difference becomes extreme very quickly. Within seconds, the stretching force would become so intense that it would pull apart not just your body, but the very atoms you're made of. The same would happen to anything else: rocks, spacecraft, even entire stars. Matter would be pulled into long, thin threads before being torn apart completely. This process is brutal and final, and it happens long before you reach the center. It's one of the reasons we'll never truly see or know what lies deep inside a black hole. Anything that tries to get there is destroyed by this unimaginable gravitational stretching. Still, even though spaghettification sounds like the end of the journey, in theory, your particles would keep falling further, down toward the mysterious place known as the singularity. And that is where the real unknown begins. At the very center of a black hole lies something called the singularity. This is where all the matter that falls into the black hole is thought to be crushed into an unimaginably small and dense point. Imagine squeezing the entire Earth, or even a massive star, into a space so tiny that it has no size at all. That's the singularity, a place where gravity is so strong, it warps space and time beyond anything we can picture. But here's the problem. Our current understanding of physics, the rules that explain how everything in the universe works, breaks down at the singularity. The laws of gravity, described by Einstein's theory of general relativity, predict that the density becomes infinite. At the same time, the rules of quantum mechanics, which govern the smallest particles, say something very different. These two theories don't agree, and this conflict means we don't really know what happens inside the singularity. Scientists believe the singularity is the ultimate mystery, where the universe's known laws stop working and something new must take over. Some think it might be a gateway to new physics or even another universe, but so far, it's purely theoretical. Because nothing can escape a black hole to tell us what's happening inside, the singularity remains hidden behind the event horizon, keeping its secrets safe. Understanding the singularity is one of the biggest challenges in modern science. To truly know what's inside a black hole, we need a theory that unites general relativity and quantum mechanics, a theory of everything. Until then, the singularity remains one of the most mysterious places in the cosmos, a point where space and time end and the unknown begins. Because no one can see inside a black hole, scientists have come up with many different ideas about what might be happening beyond the event horizon. These theories are still being tested and debated, but they open up fascinating possibilities about the true nature of black holes. One popular idea is that a black hole might be a wormhole, a tunnel through space and time that connects two distant points in the universe. Imagine it as a shortcut that could, in theory, allow travel across vast distances or even to different times. If this is true, a black hole might not just be a dead end, but a passage to somewhere new. However, wormholes remain theoretical and would require conditions we don't yet know how to create or survive. Another idea comes from something called the holographic principle. This suggests that all the information inside a black hole might actually be stored on its surface, the event horizon, like a hologram. In this view, the inside of a black hole could be a kind of projection, meaning reality as we know it might be very different from what it seems. This theory tries to solve some of the puzzles about how information behaves in black holes, which has been a big mystery for decades. Some scientists also propose that black holes could be gateways to alternate universes or other dimensions. These ideas come from advanced theories in physics, like string theory, that predict the existence of multiple universes beyond our own. If true, falling into a black hole might be like stepping into a completely different world. While none of these theories are proven, they show just how mysterious and strange black holes really are. Each one pushes the limits of what we understand about space, time, and reality itself, and reminds us that black holes may be more than just cosmic traps. For a long time, scientists believed they understood black holes pretty well. But recent research has started to challenge some of those old ideas. What if everything we thought we knew about what's inside a black hole is wrong? New theories suggest that the event horizon might not be the smooth, invisible boundary we imagined. Instead, it could be a strange, energetic surface, sometimes called a firewall, that would destroy anything trying to pass through. This idea shakes up the peaceful picture of falling into a black hole and raises questions about what really happens to information and matter. On top of that, powerful new tools like the James Webb Space Telescope and other future observatories are helping scientists observe the regions around black holes more closely than ever before. These observations might reveal surprises that force us to rethink the rules of physics near these mysterious objects. Science is always changing as we learn more, and black holes remain one of the biggest puzzles in the universe. The more we study them, the more we realize how much we still don't know, and that's what makes them so exciting. Maybe the truth about what's inside a black hole is something we haven't even dreamed of yet. Black holes are not just mysterious objects in space. They might also hold clues about the very beginning of our universe. Some scientists think that the Big Bang itself, which started everything we know, could have come from a kind of black hole in a much larger universe. This idea turns everything upside down, suggesting that black holes might not just be endings, but also beginnings. When you think about it, black holes challenge what we believe about reality. They twist space and time in ways that seem impossible, pushing the limits of our understanding. Inside a black hole, the rules we live by no longer apply, and the universe becomes a place full of endless possibilities. So what's really inside a black hole? The honest answer is, we don't know. But maybe that's the greatest mystery of all. It reminds us that the universe is far bigger, stranger, and more amazing than we can imagine. And as we keep exploring, who knows what secrets black holes will finally reveal?